In 1943, Sperry Products learned of the work being done by Dr. Floyd A. Firestone, utilizing high-frequency sound waves for non-destructive testing of materials. Sperry recognized the importance of this development as it would apply to industrial quality control and maintenance, and lent its support and engineering skill on the ultrasonic reflectoscope. Setting up a reflectoscope is not much more difficult than tuning your modern television set. A search unit is used to probe along the surface of the material under test. It connects easily to the instrument by means of a flexible cable. A standard aluminum Alcoa reference block is used to calibrate the reflectoscope screen so that the defects can be accurately located with reference to the test surface. The principle of ultrasonic inspection is fundamentally simple. Sound beamed into the material is reflected back to the source from the opposite boundary and from any discontinuities in the path of the beam. This energy is amplified electronically and displayed on the face of the cathode ray tube. The green rectangle above the block to be tested represents the viewing screen of the reflectoscope cathode ray tube. The pip at the left-hand end of the horizontal sweep line represents the generated pulse known as the initial pulse, and with the search unit placed against the surface of the block, this pip also represents that surface. The search unit projects the beam of ultrasonic vibrations into the material. These pulses travel to the opposite boundary of the material, where they're bounced back to the search unit. A pip appears at the right. The distance between the two pips represents the total travel time through the material and back to the source. If a discontinuity is present, the ultrasonic beam strikes the defect and a portion reflects back to the search unit while the rest travels on to the opposite boundary where it too is reflected back. The cathode ray tube display shows the pip from the opposite boundary reduced in size because some of the energy has been cut off by the defect. The pip appearing between the initial pulse and the back reflection represents the size and location of the defect. Its position along the sweep line represents the distance that the ultrasonic pulse has traveled to the defect and back. A system of square wave markers superimposed on the horizontal sweep line is used as a measuring scale. The Heppenstall Company consistently produces die blocks of the highest quality. Every block produced is inspected by the world's most severe critic, the ultrasonic eye. One side of the block is machined to make a contact surface for the search unit of the reflectoscope. The reflectoscope will look inside each die block in search of cracks or other defects. The viewing screen shows the verdict. This die block is perfect. It will do the job it was designed to do. Let's look into the next one. This one won't do. That indication shows us that deep inside is a flaw, which might cause the die block to fail. Its destination, scrap pile. Only those that pass this critical eye are stamped with the mark of quality. U.S. Steel checked this turbine generator shaft on the lathe at each stage of machining to be sure that no defects suddenly appear to give cause for ejecting the shaft after long and costly hours have been expended. The Wyman Gordon Company is one of the nation's leading producers of jet aircraft forgings. After facing an aluminum impeller forging hub, the part is subjected to ultrasonic testing. Testing with the reflectoscope has controlled material quality to the point where operation failures have been practically eliminated. Wing spars subject to severe stresses of supersonic flying have to be free of stress razors before they can be put into service. The reflectoscope will find out if they are. Before long and costly machining operations are performed on forgings, ultrasonic tests are made to assure material free of defects. The basic parts of this 50,000-ton die forging press, designed and built by Lowy under the Air Force Heavy Press Program, required exacting inspection before fabrication as the world's largest press. Each massive column measures 108 feet and weighs 330 tons. In place, these columns must withstand the crushing force of 100 million pounds. Because of the sheer mass of the columns, they're made up of three 108-foot sections joined together in final assembly. Section by section, the columns are inspected with the reflectoscope for any stress razor in the critical area, which might cause this Goliath to crack under the forging strain. The occurrence of such a failure could mean untold damage in plant facilities and great production losses. A two-crystal search unit technique is utilized on these castings to penetrate through the coarse grain structure and pinpoint any defects resulting from the casting process. By using one search unit to transmit the sound from one end and another to receive it at the other end, the sound is made to pass through the material just once.